So still trying to solve a fluid dynamics problem. So I problem here on screen here, they're saying quantity that two sources having equal strength located along x-axis, this and that. So let's draw what they are talking about. We have source, something is coming out. I'll represent my source with the dot, and another one here, 2, right? These and the sink located at y is equals to 2. So somewhere here there will be a sink. I'll make my sink crosses, right? And then determine the magnitude and direction of a fluid velocity at x is equals to 5. So the question one, the point we're interested in, I'm going to make them yellow. Y is equals to 0 is this, and x is equals to 5. So I think it's worth telling you that this is 5. I'm waiting to write this thing today. Okay. Yeah, I think I wanted to write that. 5. Then this is 1. No, it's not 1, it's 2. This is 2. This is 2. That is 5. So this is most likely going to be 3. Determine the magnitude and direction of velocity at this and that due to a combination of flow rate in each of the sources. So sources go with that. Sources, they are red, right? So sources, sink, are blue. And then this is our sink. So that's really interesting. Then we can try to find this distance. Look like it would be useful. So it's going to be square these things and then sum them. So I think I have 2 squared plus 5 squared because of Pythagoras. This should equals to 4, 25, 29, root of 29. So that's going to be our distance. So I could just write it instead here, root of 29. And remember the formula that I mentioned that it's going to be useful, the one that said velocity r is equals to m, where m is our flow rate, 2 pi r. The reason why we use this formula, remember your flow rates have been, from fluid mechanics, have been velocity multiplied by area. So this thing, this is velocity, this should be area. So remember, if we have a fluid and then we have this cylinder, we're interested in the volume coming in the side like this. And if I draw this thing from the side, it will look like this from the top view. This is what actually happening, right? So the area we're talking about is actually the circumference, if I should put it like that, circumference, because this, you know, this one should be your circumference. So that's why we use that. This is the same formula, actually, just the other way around. Okay, so if we can try to find this is a source, right, and this is also a source, and that is what it gets, right? So if I want to find VR influenced by, let me call this one A, let me call this one B, let me call this one C. VR by A is going to be mass it's a source, right? It's giving me 0.5. It's there. Source made them red. 2 pi r is the distance, right? 5. Then I'll get some number. I have to punch on a calculator, but let me not do that now. Pi cos by b is going to be the distance of the same flow rate is the source to the distance now become 3 like that. Then I'll use my calculator, and then r by a is a sink, c is a sink, this one is a sink, so it should have some negative 1 all over 2 pi. The distance is root 29. Then I'll compute all these values. Let me get my calculator. So after computing, I got these values. I hope that I didn't do any mistake. So yeah, but this one is pushing on this direction, that one is also pushing in this direction, but this one is pushing at some angle that look like this. So I think if you write this one, you'll be interested also in the angle. So it's actually going the other way. Let me put this, it's going to go like this, and you'll be interested on this angle. Okay. And then that angle you can just find by saying arctan of opposite 2 divided by 5. And then that theta is going to equals to 21.80 degrees. That is going to be my angle here. So this one has horizontal and vertical components. So if you want to sum up everything here, we'll have to consider that. So I think I'll show you the method on my calculator how I end up velocity at, let me call this point 1. Velocity at 0.1. I'll show you the method how I actually do this on the calculator. I think it will be very useful. I use a tricky way of using complex numbers. I know that someone might think it's easy to work with complex, your vectors as x and y, but that one does it beautifully, trust me on that. But let me compute and come back with the answer. So I skip all the method how I got up to this. I'll have to do a video on how I use my calculator just to save my time doing all that. So I think now we solved the problem, didn't we?